Okay. All right, everybody. I think we are going to get started. So thank you very much for joining us today for this introduction to an initiative we're really excited about, the Atlantic Wind Energy Supply Chain Assessment and Pathways for Supply Chain Development Project. My name is Elisa Oberman. I'm the Executive Director at Marine Renewables Canada, or MRC, and I'll be your host for today. And I'm also joined by Amanda White, our Operations Director at MRC. For those of you that might not be familiar with Marine Renewables Canada, although I know we do have a lot of members joining us, but for those of you that don't know too much about us, we're the National Industry Association for Tidal, Offshore Wind, Wave, and River Current Energy. And a really core part of our mandate is to support and facilitate development of the Canadian supply chain for marine renewables. So hence the study that we have underway right now. As we get started, I do want to take a moment to recognize and acknowledge the traditional territories and Indigenous peoples of the different lands that we are all on today. I'm hosting this webinar from Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. So a bit about the purpose of this webinar, and then I'm going to hand it over because we have not a lot of time to talk about everything we need to get through today. But as a lot of you are aware that are joining us, there's a lot of activity underway in Atlantic Canada when it comes to wind energy. And there's an increasing focus on developing both onshore and offshore wind resources to help green the grid and pursue green hydrogen opportunities both domestically but also for export. So we're at a really exciting time when it comes to wind energy, but we've also recognized that to ensure that it's successful and that we see sustainable growth of the sector, we really need to have a strong, robust supply and workforce to support project demand. So with that in mind, and with support from Atlantic Canada Opportunities Agency, or ACOA, Nova Scotia Department of Energy, and Prince Edward Island Energy Corporation, MRC has commissioned a study that will assess the opportunities, strengths, and challenges in the existing Atlantic Canadian supply chain and identify pathways for ensuring the region has strong capabilities and capacity to support growth of offshore and onshore wind. So given the importance of this project for the region, we really wanted to ensure that local suppliers were aware of the work underway and also had an opportunity to engage. So I'll take this quick opportunity to thank all of you for filling out the intake form that you would have had to fill out for the registration process. We know it was a lot of information to provide, but that's really going to go a long way in providing input and information that will be useful to the project team. So getting back to today's webinar, it's going to give you some more information about the project, what the scope is, the goals, the overall objectives, and it's also going to provide an overview of what is entailed in project development and execution process for wind energy projects. So this will hopefully give you a better idea of where you might fit in the supply chain, and also what products or services are required to support both the offshore and onshore wind industry. So with all that in mind, I'm going now to get into introductions, and I'm joined here today by some of the project team who were contracted to lead and conduct the study. So shortly you're going to be hearing from Delia Warren, who is the lead renewables consultant with Xodus Group, who's leading the study along with partner Envigour Solutions, Envigour Policy Consulting, and an expert team of local industry advisors, with some of them that are here today. So before I hand it over to them, just a few quick housekeeping notes that all attendees should be aware of. You'll notice that we are recording the webinar. So for those of you that have registered, you'll receive a link to the recording afterwards. And the bulk of the webinar is going to be a presentation that will then be followed by a question period. So the idea today is really that you can provide some questions and get answers to some of the things you might be wondering about with the study, but also steps after that. And we're going to try to get to as many of them as we can today, but if we don't, we'll try to sort out a way that we can get some answers to you. So without further ado, I just want to thank Delia very much and your team for being here today, and I will turn it over to you to introduce yourself and the project team and get started with the presentation.
Thank you very much, Elisa. I'm just going to go ahead and share my presentation. Alrighty. So as we get started, as Elisa mentioned, my name is Delia Warren, and I'm a lead renewables consultant with Xodus Group. Xodus is a global energy consultancy based in Scotland. I work out of the Boston office where we work exclusively in offshore wind, but I am a Newfoundlander born and bred. from St. John's, Newfoundland and Labrador. So let's get started. So the purpose of this webinar, besides sharing what we will be delivering under this scope, is to provide information about offshore and onshore wind supply chains to local companies and workers, such that it will be easier for you to see where you could potentially fit. We wanted to gain information about who was interested in learning more about offshore and onshore wind opportunities, which was the reason for that lengthy intake form, as Lisa mentioned. And finally, we knew it wouldn't be possible to contact every single company that we assessed, so we really wanted to give local companies an opportunity to comment or ask questions as part of the study to really feed in and give us that local context. Also, before we start, I know that there's going to be varying levels of knowledge and understanding about the different wind industries on this call. So I'm going to try and speak in a way that everyone here is able to benefit from the information. And I'll just ask to please note your questions and keep them for the end. If we run out of Q&A time, there are contact information for the other project team members and myself at the end, so you can reach out via email and ask us those questions that way. So today we're going to start with project overview, industry overview. We'll discuss taxonomy and contracting structures and define what taxonomy actually means. We'll go through the offshore and onshore wind supply chain and discuss some challenges and opportunities that we've observed so far. And then at the end, we're hoping to have 20 minutes for a Q&A. Okay, so to get started, this is a project where we're looking at offshore and onshore wind supply chains for the 4 Atlantic Canadian provinces, led by MRC with funding from ACOA, Nova Scotia Department of Natural Resources and Renewables, and the PEI Energy Corporation. And again, I'll just call out my fantastic partners on this project: Envigour Solutions, based in St. John's, Envigour Policy Consulting, based in Halifax, Xodus Group, also based in Newfoundland and Labrador, and then Xodus Group, which is based in New Brunswick, and as well as Eric Christmas, who's acting as an Indigenous liaison for this project. So essentially, the objectives here are to understand current supply chain capabilities and gaps, to analyze industry requirements and timelines, identify investment opportunities for public and private sector, both locally and internationally, to build awareness of partnership opportunities and understand workforce requirements, and then ultimately to develop actionable recommendations that will maximize economic benefits to Atlantic Canada and ensure a sustainable and inclusive wind energy supply chain. So a lot of this research is desk-based, but we've supplemented or will be supplementing the research with insight gleaned through stakeholder and rights holder outreach. So the stakeholder categories we've been engaging with include academia, innovation, advocacy and economic development, industry organizations, government, et cetera, et cetera. And that's really aimed at establishing an understanding of each province's renewable energy ambitions, programs that exist or that are planned to support supply chain building, sentiments around wind energy developments, and perceived opportunities and strengths, as well as gaps, things that you can't find from doing internet research. So Indigenous engagement is obviously a critical component of this work and the general build out of the wind energy industries in Atlantic Canada. So as such, we've taken a very thoughtful approach to Indigenous engagement with Indigenous liaisons leading outreach, focusing primarily on the economic development branches of Atlantic Canadian Indigenous organizations. The renewable energy industry in Canada has seen very strong growth in Indigenous ownership. So that's one aspect that we're really focusing on. And you can see that over the past decades, how much this has increased as the number of projects in the space has increased as well. But the number of projects, the proportion that are Indigenous owned or part owned has really increased. So I mean, in the news today, the Canada Infrastructure Bank provided over $200 million to help with Port Hawkesbury's Paper Wind Limited build a large-scale wind energy project, and that's got a 10% stake for WMA, which represents 13 Mi'kmaq nations. So federal financing is a major opportunity to increase Indigenous participation and ownership in this industry, or these industries, I should say, onshore and offshore wind. So engagement here is based upon experience in the offshore petroleum supply chain ventures and onshore renewables investments to identify opportunities for Indigenous enterprises and partnerships. So we really are trying to understand the relationships that the various Indigenous communities in Atlantic Canada desire to have within the offshore and onshore wind industries, and then we can tailor our recommendations around supply chain building to match those aspirations. So really listening and not being prescriptive here. So the major part of this scope of work, or the central focus, I should say, is the supply chain assessment of companies. So as part of this scope, we're doing an analysis of the current state of offshore and onshore wind development in Canada, doing some forecasting of future developments, and reviewing industry and supply chain requirements. But our team is also conducting a desk-based supply chain assessment of existing companies in Atlantic Canada to determine their ability to support offshore and onshore wind supply chains. So this consists of categorizing a list of existing companies according to offshore wind taxonomy, which is basically a fancy way of saying that we use standard language to describe project life cycle activities. So here in the red, we've got project development. In the green, we've got manufacturing and component supply. The blue is installation and commissioning and transportation activities. Purple is operations. The next one is decommissioning. It's kind of orangey, but you can't really see that. And then finally is sector support. And so that's what we mean when we say taxonomy. So basically, this is carried out using publicly available data about the company, looking at their stated capabilities on company websites, reviewing past projects and press releases, assessing company's size and reach, and then using the project team's experience and expertise in wind energy supply chains to make judgments on the company's potential to support offshore wind. So we've assessed them all based on supply chain element, which is along the bottom. I know that's hard to read. I'll go into more detail later in the presentation. And basically, after we map the companies to these various supply chain elements, we rank them on applicability. So high applicability companies would already have experience in the industries, would require very minimum investment to scale or retool or obtain necessary qualifications to enter the offshore wind supply chain. Moderate would be middle of the road investment level. The company likely would not have experience. And then lower applicability companies do not have direct onshore offshore wind experience, but do have products or services that resemble those needed in onshore or offshore wind, but would need significant investment and changes in operations to enter the supply chain. So basically, after we do this desk-based assessment, this is the type of output we would get, this graph. And I will note that this is not final. There are still more companies left to assess, and we want to review these results for quality. But this does give an indication of how we'll be presenting the first pass of the supply chain assessment. And then in addition to this general supply chain assessment, in parallel, we're carrying out a supply chain diversity assessment to promote equitable opportunities for underrepresented groups. So that includes racialized persons, persons with disabilities, women, and members of the 2S LGBTQIA+ community. So typically companies that would be owned by those groups. So where applicable or where available, we will assess this information as part of our desk-based assessment, and then make some observations and recommendations on our observations there. So key considerations here include the application of regional context to supply chain diversity, encouraging diverse leadership, and fostering broader industry inclusion. All right, so finally, we will be presenting the outcomes and recommendations of this study in April 2025. We'll be physically presenting them in the 4 provinces, and we'll be hosting a webinar. And the report will be available in some form, maybe a condensed form. We're still working out the details on that as of April 2025. So this will include the results of the supply chain assessment, including the insights and observations that we are able to extract from this work a SWOT analysis. We'll be presenting things in an easy to digest way with regards to the current state of the supply chain using a scorecard. And then we'll make short, medium, and long-term recommendations for recipients of the report in order to focus on equitable and sustainable supply chain build-out. Okay, so that's the project. That's what we've been working on and are continuing to work on until April. Now, before we dive into the details of offshore and onshore wind supply chain requirements, we're just going to do a little kind of crash course into the different types of wind energy technologies that we'll be discussing. So the study focuses on three primary technologies. Fixed and floating are both offshore wind technologies, and then onshore wind. Fixed offshore wind foundations are physically embedded in the seafloor, and you can see examples of the various types of foundations in the graphics here. Floating offshore wind has a substructure that is floating and tethered to the seabed using mooring lines, which can either be chains or synthetic rope and anchors. And this is typically done in water depths greater than 60 meters. Offshore wind is more expensive and logistically complicated than onshore wind, which is a much more mature technology. But you're able to use turbines that are much larger and access wind resource that's stronger, that gives you higher capacity factors. So you're able to generate more energy per structure for offshore compared to onshore. Because of the size of the components for offshore wind, manufacturing is typically required to take place quayside, and components are transported using vessels, whereas onshore you're limited by the ability to transport components over land. So they're not able to get as big as offshore wind turbines. Offshore wind is used primarily, despite it being more costly and logistically complicated, to locate generation next to demand centers. So what does that mean? Often next to great big cities that have a lot of energy requirements, there's not a lot of available land onshore to build an onshore wind farm. So being able to put offshore wind farms that are generally in proximity to these large cities is really beneficial, especially if they have aspirations for decarbonizing their electrical systems. Excuse me. So with regards to onshore wind, in Atlantic Canada, it is a much more mature industry, both in Canada and beyond. Canada does not currently have any active offshore wind projects, although globally there are nearly 70 gigawatts of installed offshore wind capacity, and it's thinking that there's going to be more than 200 gigawatts by 2030. So that is a significant build out and a significant amount of installed offshore wind. And while both Nova Scotia and Newfoundland and Labrador have conducted regional assessments for offshore wind, and the respective offshore petroleum boards will soon become offshore energy regulators to take offshore wind under their mandate, only Nova Scotia has set a target for offshore wind thus far. So they have 5 gigawatts of developable seabed capacity that they plan to lease by 2030, just as a start. But with regards to onshore wind, Canada is actually in the top 10 globally with onshore wind capacity installed, so at around 17 gigawatts. And 1.3 gigawatts of that is in Canada, Atlantic Canada, as you can see here in the table there below. So provinces are currently planning to integrate a lot of additional onshore wind into their grids for use, but green hydrogen development could vastly increase that amount of onshore wind capacity being developed. There's also been recent mention of data centers using the strong wind resources of Atlantic Canada to power their operations. So you can see in this table, we've got the installed capacity and additional planned capacity. In the red, you can see what that capacity would jump to if all the planned green hydrogen projects were to go ahead. And I mean, you can see in Newfoundland and Labrador up to 28 gigawatts of onshore wind is quite something. So onshore wind is very well established in most of Atlantic Canada, even though NL lags slightly due to the wind moratorium, which has now been lifted. And there is a supply chain that exists for onshore wind in Atlantic Canada. The ambition of Newfoundland and Labrador to develop so much green hydrogen is primarily driven by Crown land. there is a lot of crown land. And there's also active large-scale green hydrogen development in Newfoundland or Nova Scotia and New Brunswick, which is planned for to be supported by offshore wind. So this is really going to drive further growth in the existing local supply chains. And if the green hydrogen projects are progress, then that will definitely stress existing supply chains depending on the timeline and scale of development. But that there's currently a lot of uncertainty around that right now. Hopefully we'll see that firm up as time goes on. Okay, now we're going to get into taxonomy and contracting structures. And this is important because it's how we structure the supply chain assessment and how you will know where your company fits within the offshore and onshore wind supply chains. Okay, so by using standard terminology or taxonomy, we're able to more accurately describe where a company will fit and who they are likely to contract with, also what their scope of operations would likely be. So this approach is closely aligned with typical industry contracting structures and comprises multiple supply elements that describe the requirements for products and services that enable projects development, construction, and operation. So we will go into contracting structures just after this slide. But typically, when we're referring to offshore and onshore wind taxonomy, and we've got a joint taxonomy that represents both onshore and offshore industries here, we refer to it as major packages. So it starts with project development. The next package would be manufacturing and component supply, which includes the wind turbine generator, nacelle, rotor, tower, and then the balance of plant, which is all the physical infrastructure other than the wind turbine generator that's manufactured or supplied. The next package is construction, transportation, installation, and commissioning, followed by operations and maintenance, and sector support, which spans all other packages. And we'll go into more detail on that later. I just want to introduce it so that the next slide makes sense. Okay, so this graphic represents the various contracting structures that you typically see in wind energy, ranging from multi-contracting through hybrid contracting to EPCI contracting. And as you go towards EPCI from multi-contracting, you're essentially reducing the interface cost and schedule risk, as well as the project oversight that's required by the developer. So you're shifting risk away from the developer. So there are, like I mentioned, there are three main contracting structures. They're really determined by the size and complexity of the projects, the internal strengths, experience, and capabilities of the developer and the tier one suppliers, the influence of project financing and availability, the maturity of the local supply chain, and the amount of risk that the project developer is willing to take. An engineering, procurement, construction, and installation, or EPCI, contracting structure transfers the risk away from the developer, but does require experienced and competent subcontractors. So here you'd basically be grouping the major packages. You might have 2 or 3 contracts where you would see tier ones taking a major responsibility over construction, installation, and design. This is what you see more often in onshore projects, given they're essentially civil works projects, and the industry is significantly more mature than offshore wind. And then on the opposite end of the spectrum is multi-contracting, where the developer takes on much more risk as they're managing several different contracts across the project packages. So I know this is a little bit confusing, but it does, it's something that you need to know early on when a project is getting built out. So as the offshore wind industry becomes more mature, it's shifting from a multi-contract approach through hybrid contracting where packages may be combined. So as you can see here with the dotted lines, foundation, supply, and installation could be grouped together and managed by a single entity. Floating offshore wind is still very immature and is likely to be multi-contracting focused for a while, at least until that develops more maturity. Okay, and then finally, with regards to the terminology and taxonomy and naming nomenclature of everything, we'll talk about actual supply chain technology. So this standard terminology is employed to simplify discussions with various contracting structures. across the various contracting structures. But it isn't always so straightforward. So if you're using an EPCI contract structure, tier 2 might be a tier 1 versus in multi-contracting. So again, this is relevant to the structure that's employed for the project, but it permits us to discuss where in a supply chain different companies are located. So as you can see here, we're going to start with the developer. The developer is the owner and usually, but not always, the operator of a wind farm. They lead the project development activities and are ultimately responsible for financing the project. And I've put here under the developer column examples of some of the common developers that are in the industry. And then under all the other headings, you can also see companies that can apply as OEMs, tier 1s, tier 2s, tier 3s. So OEMs are original equipment manufacturers, and they produce the major components of the wind farm. So the turbines, cables, foundations, etc. Tier 1 suppliers can be any company that contracts directly with the project developer. So with regards to the wind industry, OEMs are technically also tier 1 suppliers. Tier 2 suppliers contract directly with tier 1, tier 3 with tier 2, and so on and so forth. For the most part, opportunities for local companies are at the tier 2 level and beyond. And we tend to look out to about tier 3, sometimes tier 4 in this study. And we'll go into some more details about what that looks like as we continue. Okay, so now we're actually going to dig into the requirements of the offshore and onshore wind supply chain. We'll go through each of the packages and discuss what's being bought, who's buying it, when the contract needs to be signed in relation to the project's commercial operations date or COD, and talk a little bit about specifically what goes into each package. All right, so the first package is project development. So here you see that there are supply elements associated with each supply chain area. So that's here we've got under supply element project management, permitting, onshore surveys and environmental work, offshore surveys and environmental monitoring, engineering and design. And then in the second column, you see fixed, floating, or onshore wind, or all. And that's going to basically describe where each of these supply elements are relevant as we're assessing offshore and onshore wind together. And then details, we'll give some details of what is actually involved in that supply element. Oops, sorry about that. So here the buyer is the project developer, and they may have multiple contracts under each of these supply elements. They're buying, permitting services, environmental impact surveying and assessment, med-ocean resource assessment, onshore site assessments, engineering and design. They may even look for project management services, financial, legal services, and consultants that can do any number of those things. They're buying this up to 10 years before the project COD. That is more applicable to offshore wind than onshore wind. Onshore wind, you would see this timeline drastically shortened, but keep in mind for offshore wind, you've got about a 10-year development timeline. So you need to get in the door early if you're looking for a contract in this space. This is sourced competitively by the project developer, but they will all often use a local bias, especially with things like surveying, where a local company may know the area better and be able to provide efficiencies in that way. Next is the manufacturing and component supply. So here, the supply elements include major industrial electrical equipment, minor electrical equipment, so things that are more off the shelf or less operations critical. Industrial motion precision fabrication, so things like the gearbox, motors, shafts, the blade supply, including raw materials. Major steel component supplies, so that would be everything required to make the foundations, the transition pieces, tubular steel, steel plate, pin piles. Mooring supply, so chain and rope, connectors, cable supply, Ancillary equipment supply, so things that you need to get the jobs done, get these things built, forklifts, cranes, tools, welding, corrosion protection, and then vessel design and build, so shipbuilding, retrofits, repairs, all that stuff. So basically, during this process, the developer could be hiring the OEMs, the various OEMs could be doing the subcontracting, and even some tier 1 and 2 suppliers. So this is a very, very large package. It's the highest CapEx cost or the highest cost across the whole project is CapEx for these items. And so it is the area where the biggest spend is made. They're buying this typically 2 to 3 years out from project construction. For large scale onshore projects, it's likely to be a similar time frame because of the long lead time needed for large orders. For smaller projects, you might not need such a lead time for onshore, but for offshore, you certainly will need at least 2 to 3 years. And then procurement approach here, it varies based on the contract approach and the local content requirements. So OEMs will typically have multiple vetted tier 1 and 2 suppliers for redundancy. And because the onboarding process to be a tier 1 or 2 supplier for an OEM is very arduous, time consuming, expensive, detailed, it could take multiple years. To be subcomponent suppliers, not quite so arduous, and things that, may be required for quayside assemblies, such as lifting frames, SPMTs, cranes, storage frames, all those things that would be better sourced locally. And so they may put priority on that. Next is the construction, transportation, installation, and commissioning package. And here we've got onshore and offshore installation work, electrical commissioning, onshore logistics, and offshore logistics, vessels and marine logistics. Again, developers, tier 1 and tier 2 service providers are buying things like port and marine services, support vessels, marine coordination, weather forecasting, etc., out to 3 years before the construction starts. And this is typically done on a competitive basis by the tier 1 providers, and they're looking for experience here. This is an area where partnering would be a really great option, partnering with a more experienced firm to leverage skills developed in, say, the offshore oil and gas industry or the mining industry that you could then apply to this industry. Okay, second to last here, we've got operations and maintenance. Now, this is a very key package for projects from a local perspective because they're operating for up to 30 years. And so even though the majority of the volume of job creation happens during manufacturing, the long-term job creation is during operations and maintenance activities, even though the number of jobs is less. So here, the project developer is primarily responsible for contracts during operations and maintenance, the operations and maintenance period, but there may be a third-party service provider or a wind turbine OEM that's also doing contracting here, as warranty periods on turbines can be quite extensive. In onshore wind, that you can see them lasting the life of the project, so you may be contracting with an OEM. So here they're buying offshore inspection, maintenance and repair services, port and marine services. When you're doing a major component replacement, it looks a lot like an installation operation. This is ongoing for the duration of the entire project. And you need to understand, for instance, what the warranty period is on the turbine to know if you're going to be contracting with the developer or with the OEM. For instance, if you are a rope access company that is doing blade repair, for instance. So here, there's lots of opportunity to get to hire locally here. It is source competitive. There is local bias given that you want to be close to the project in order to respond quickly to issues and to perform maintenance. And then finally, sector support. So this, like I mentioned, this is something we don't always consider this when we do supply chain studies, but this is really critical at an early stage in terms of getting a supply chain up and running off the ground. So all tiers are buying here, all manner of support services, including security, snow clearing, training, PPE provision, etc., professional services, food, accommodation, storage, office space. Again, this is the duration of the entire project, and it's sourced competitively with a local bias where possible. I would say the local bias here is something that can be enforced by the jurisdiction where the project is operating. This is kind of like the low-hanging fruit. A lot of these groups or companies will not be so industry specific and are more able to pivot to respond to the needs of the industries. So that is that for the supply chain overview. I know I went through that very quickly, but feel free to ask questions if you need some additional clarification. I'm just going to go through a brief overview now of the challenges and opportunities that we've observed so far in this study. And just keep these in mind as the industries build out. So first off is supply chain bottlenecks. So given the substantial volume of onshore wind that's in the pipeline right now, there are anticipated labor and equipment shortages, things like transportation of onshore wind components, cranes for installation operations, all of that. So there's a major opportunity or necessity, you might even say, for provinces to collaborate and share information to smooth demand and maintain consistent project pipelines. So that's something that everyone's kind of keeping an eye on. Global wind energy build out, both onshore and offshore, is going to put major strains on existing supply chains. It's currently outpacing the growth in manufacturing across the board. So there will be opportunity to export products and services. One thing that we consider in this industry is that there are limited pathways for offtake, which may limit build out of offshore or onshore wind in the region. However, that does not necessarily mean that any skills services developed in support of the industry locally can't be exported. So that's a major consideration when we think about how far can these things go. With regards to adjacency and transferability of knowledge and skills, there is a high degree of adjacency, which is another way of saying transferability, of skills, expertise, and assets in Atlantic Canada's civil and marine industrial sectors. Some companies require scaling, upskilling, recertification, but others are ready to hit the ground running and are already participating in offshore wind. And with regards to onshore wind, like I said, there's already an existing supply chain that is just ready to grow. So being educated on this opportunity, the timeline of project build out, and where your company fits is crucial at an early stage. Like I said, those timelines are quite substantial. So the more you know, the earlier, the better. Understanding local content. So local content basically refers to the amount of local spend, the number of local contracts, the degree to which the local workforce is utilized. So it's been observed in other jurisdictions that maximizing local content can and does drive up project costs and slows timelines. So when designing the optimum amount of local content for projects, it's necessary to find that balance and create partnerships. Nobody will want the project if the local content means that the electricity at the end of the day is way too expensive for the end user. So those are the things that you have to weigh. Providing incentives and supporting full and fair opportunities for local entities should create local opportunities. This is something, again, that has been put into practice in other jurisdictions. Some places legislate local content requirements. Some places put it in their offtake agreements. Sometimes there are penalties for not reaching them, and other times the language is a lot more light. But this is a great way of stimulating local growth and local economic activity. And the greatest opportunities will lie at tier 2 and beyond for local content for local companies, and companies need to know who to contract and partner with. Then finally, a challenge in this industry for everybody, all sides, is access to up-to-date information. So project developers and tier 1 suppliers are often very busy with project or package management and compliance tasks. They've got a lot on their plate. Many don't have the time or want to spend the money on learning about local companies, especially if it's not something that they're required to do. So it needs to be made easy for them. So in this vein, economic development, industry, and advocacy groups, they can fill gaps to make it easier through doing things like hosting educational webinars like this one, so that when suppliers go to potential contractors, they are educated on the industry and they are familiar with requirements. They can host or help to organize meet the buyer events, actively coordinate with developers in tier ones, and so on and so forth. So there is a role in intentional supply chain building. Okay, and just before we clue up, this is a list that we've developed as following observations that we've made in other places that initially had very low levels of supply chain development, but were able to build as the industry built. So this is just an example of where we have seen local contracts awarded in wind energy projects. So I'll just go through like a very high level smattering of them. So in project development, you're seeing feed scopes, you're seeing EIAs, electrical design, legal, financial services, all of these you're seeing going to local companies. With respect to manufacturing component supply, like I said, it's typically things that are at a tier 2 level, so not the major components, but things like access ladders, cable trays, work platforms, lifting frames, and then like off-the-shelf components like fasteners, or transportation services, as well as millwrights, welders, all the construction trades. In construction, transportation, installation, and commissioning, local vessels are often used for crew transfer, for guard vessels or pilot vessels, leasing of local equipment, so cranes, generators, lots of other things along that, SPMTs I mentioned earlier, and then operations and maintenance, inspection tasks, PPE supply, port services, that's almost required to be local, and inspection services. These are things that we've seen local companies be able to really dig their teeth into. All right, so thank you so much for your attention. I'm going to shift into QA. I hope I didn't go too much over time. I'm just going to present the various members of our project team. You might have seen them at the start of the webinar. Myself, Delia Warren, I'm the project manager. Karen Hawko of Karen Hawko Group. She's our DEI lead and the Indigenous liaison in Newfoundland and Labrador. Chad Lafitte is with Angler Solutions. Neil Jacobson was with Roxham Advisory and Consulting Services. Bruce Cameron with Envigour Policy Consulting, and Eric Christmas, who is our Indigenous Outreach lead. So I've got all of our email addresses there if anybody would like to reach out for any reasonable reason. Okay, and now we'll go into the Q&A. So I'm going to end my sharing of the screen now.
All right. Well, thanks, Delia. That was a really great overview, and I know you have packed a lot in in the time that we had. So just a reminder to attendees, please feel free to use the Q&A function to provide or to ask questions. We also, I think now the chat function can work for you as well. And we did have a few comments / questions come in, but I'm going to try to phrase them as questions because I think they lead to some things that are important for us to think about. And you covered some of these, Delia, when you talked about some of the bottlenecks and challenges when it comes to the industry. But one was around vessel availability. And the comment was, the fact that globally there's a shortage of vessels that can be used for offshore wind and waiting times of, up to 2 to 3 years, or to get on a list to use a vessel. So obviously we're early stages, and some of the work that you're doing with this study is also going to flag that issue and potential steps that government or others could take to address it. And we don't have that yet in terms of a strategy, but I'm wondering if you would be able to comment a bit on what's been done in other jurisdictions around this issue, maybe the US in terms of, that seems to be has been an issue there as well. Would that be something you could speak to?
Sure, yeah. So, supply chain issues have caused a lot of headaches in projects in the US. So being based in Boston, my experience is primarily in the US offshore wind industry, which hasn't really been smooth sailing since the start. And a lot of that is due to things like vessel availability and supply chain bottlenecks. So, I mean, doing studies like this, consultants right now, when there's problems in the industry, that's when it's really our time to shine and do those supply demand studies, looking at the availability of vessels, looking at the availability of various components, looking at the timelines of build out and flagging when there's going to be issues. That's really a critical way to look at the supply chain build out and how the industry works. And it's been a big challenge. I know New Jersey, for instance, they had to cancel projects because they did not have vessels available in the window that they had to do the installation. It was a really big issue. And there's a lot of competition. In the US right now, the Jones Act has really limited the ability of various global vessels to participate. The Jones Act is basically it requires that any materials or personnel transported between two U.S. ports of call, and once you set your foundations, an offshore wind farm is a port of call, need to be done on U.S. built, owned, and crewed vessels. So there's currently one wind turbine installation vessel, which is a highly specialized jackup vessel that was built in the U.S. and qualifies for the Jones Act. That's a Charybdis. And otherwise, they have to use a feeder barge approach. So that's really complicated the installation processes, but it's also led to some innovations, which have been really interesting. Anyways, I'm not sure if I answered the question or if I just went on a tangent there, but
No, I think it's helpful. I think it was helpful. It wasn't phrased. I tried to phrase it as a question because it's just an important point for us to be thinking about. And along those lines, there was another comment around workforce shortages and the fact that there's also a lot of shortages globally for offshore workers. And I think maybe the way I'll phrase this question is, can you speak a little bit to how you're addressing workforce and labor with the work that you're doing right now? I know it wasn't, I will say to everybody that's attending this too, that wasn't a key focus of the study. It was really on supply chain generally, without getting too deep into labor and workforce. But if you could speak to some of the ways that you're kind of touching on that, that might be helpful for some of the attendees as well.
For sure. So one aspect of this project that we didn't go into too much in this webinar is development scenarios. So we are doing forecasting with various considerations to basically build out low, medium, and high build out scenarios that we're then using to make estimates on workforce numbers. So we have been able to map job roles to the offshore and onshore wind project life cycle. And with some simplifying assumptions, we'll be able to basically map when the most people in what sector will be required. We're looking right now at the various levels of educational attainment or experience that are required to do certain jobs, ranging from, skilled trades, specialty trades, professional, standard laborer, scientific professionals. And then we'll be able to kind of backcast when the training would need to start, how many people would be required to be in that training program, how many people are already trained and would be able to transition into the industry with minimal upskilling based on that. So that's really going to be linked to our the development scenarios that we're looking at.
Great. Okay. Yeah. Thank you for providing some background on that. And I think for those that are attending this as well, the idea, and Delia mentioned this too, is that the idea behind this work is that it will provide recommendations that then MRC and other organizations and government will try to drive forward, because we do, there's a lot of work that needs to be done. But as Delia had also mentioned, it's about a 10-year timeline for offshore wind, shorter for onshore. But this will help us hopefully get to a point where we're not faced, with dramatic challenges when we get to that point. There was one other question here that just came in around, and this is kind of logistical, but around just the timeline for suppliers to complete the supply chain study questionnaire. And I'm assuming that means the intake form. So some may have not provided it fully. And so I'll just provide an answer to that. I think if anybody still hasn't filled that out completely, feel free to go back in and you can fill it out by, I'd say, end of day today would be helpful. And because we're going to be passing it along to the consultants and the project team here afterwards. Another question's come in. I'm just going to read it verbatim. You may have included seabed preparation in one of the broader topics. In addition to boulder removal, these include OXO/MEC risk assessment and mitigation, debris investigation removal, and archaeological site investigation. There's also the requirements for cable trenching, scour protection, etc. So I think that's just an add-on. And I think Delia, what we'll do is take some of these comments and provide it to you, so it might help with your assessment and things that you consider as you move forward.
Oh, definitely, yes.
And another one that just came in. So wondering where advanced manufacturing, including additive manufacturing suppliers, would get involved. Which supply tier, if any, or would these suppliers be too small in scale and just have to work with tier 2s and tier 3s as the need arises?
Sorry, I'm just reading it myself.
Yeah, no, that's the challenge sometimes with longer questions, is to make sure you get the full gist of it.
I mean, it really depends. I mean, nobody likes that answer. It depends. But I feel like there's definitely an opportunity at least to work with tier 2s and tier 3s. For things like digital warehousing, that's something that I could definitely see being integrated. They're trying to digitize and automate a lot of aspects of the wind industry to get costs down. So anything that is, tested and available, that companies would be willing to use. I'm seeing that in the US, people adopting new technologies, digital twinning and all that stuff. So I could see that being employed. With respect to, I'll admit that I'm not entirely sure what additive manufacturing refers to. So if anybody else is able to feed in on that, they can go ahead.
Sure, I can actually. So I know, actually know the company that's asking the question there. It's an interesting question. It's about 3D printing and using advanced 3D printing technology as part of the supply chain. And it is too early to determine where suppliers are going to be, but I think it's important for those with these types of specializations in digital advancements, educate the developers to let them know that this is actually available in a localized area. So I think there's an education around this for sure. And it seems to be, a good opportunity going forward, because it could add a lot of value, having that a beachside diversification in the supply chain.
If I may add to that, it also raises the question of how do people get the opportunity to engage.
Yeah.
And it does get into some of the things that we'll be talking about at the end in our final report on recommendations for tools that governments and trade associations, academic institutions, research centers, that they all have opportunities to have engagement sessions with developers and tier 2 and tier 3 potential suppliers, particularly once the licenses have been granted and people have a vested interest in starting to explore how their projects will go forward. We really need to have those kind of trade shows and reverse things that we've learned from the oil and gas sector that work to build up the capabilities and knowledge and awareness of the supply chain. So we would think that any sensible government, having seen these tools worked in the past, will look for them in the future. But we would look for a lot of that activity to start happening in 2026, I would guess.
Okay, so we've had a few other questions come in. One, not necessarily a focus of the study, but I think you can probably comment on it briefly. So can you comment on how other jurisdictions model their royalties arrangements compared to typical oil and gas models? So essentially, what have other jurisdictions done with offshore wind when it comes to royalties, that type of thing? Does anybody want to comment on that? I know it isn't a focus that you really have with the study, but
I'd
you
like-
don't have to
You got
comment.
something to say.
Let me have a shot at that, because it certainly, when I was with the government of Nova Scotia, we looked at what role royalties would play in marine renewables generally. And I think it's fair to say that it's a bit of a problem, because if you're trying to have an offshore wind sector that is going to feed into a domestic market, then any royalties that you extract from that sector will be a cost input into electricity rates domestically. And therefore, it doesn't really make a lot of sense to go for very ambitious additional revenues to come out of it, knowing that it's going to get passed on to electricity suppliers. So that's one. And then on the other hand, if you're exporting, if you're using the offshore wind to create an export, then to a certain extent you say, I don't care. It's not my problem anymore, except that it does come back to being a problem for the jurisdiction in which you're developing the wind, in the sense that you may be pricing whatever product is going to be exported out of the market. And in a global competitive world, that's a challenge. So one would suspect that the royalty regimes will be rather narrow and nowhere near the kind of regimes that have generally been there in the petroleum. Although one of the lessons has always been that you have skinny royalties up front, and then when the project is paid for, you might look at something more generous in the end. And that's our lesson, both in Nova Scotia and Newfoundland and Labrador, about how to balance off all the considerations I just spoke to.
Okay, thank you for that, Bruce. And there's a few questions have come in. I'll take the one last one. And it is around whether there is currently any planned regional cooperation to develop a regional supply chain between Canada and the US to support offshore wind. I'll actually comment on that, but others may have something to say. And this is just, for everybody's information, but the New England governors and Eastern Canadian premiers recently signed an MOU, I believe it was an MOU, but an agreement this past fall on exactly that. So regional cooperation around offshore wind supply chain. And I believe that there has been a working group, or there is going to be a working group established between different governments to help pursue that and advance that directive. But I'm not sure if any of the panelists have anything else you want to mention around that, or work that you're seeing that's underway.
Well, I can definitely say that there's interest in collaboration in the northeastern US. I've given a few presentations on opportunities for supply chain collaboration in Connecticut and in Maine. And I had a meeting this morning with someone from the University of Maine about potential collaboration and information sharing for floating offshore wind. So there's definitely a lot of interest. And I think that's starting to get a bit more firmed up, like Elisa mentioned with the MOUs. But yeah, it's definitely a major opportunity, I think, for mutual support.
So we're at time, and I know that a few questions have come in. So what we're going to do is we will try to actually see if we can answer those and provide that kind of in the post webinar communications to everyone, just to ensure that everybody has the information that they're looking for. But I do want to thank Delia and your entire team for being here with us today and just providing this overview and working to engage the local supply chain and provide information I think is going to be really important as we move forward with the project. For any of you that are attending, if you have more questions, just feel free to get in touch with us. And as you saw, Delia also put up the email addresses of the entire project team, so you're welcome to get in touch with them as well. And last thing I will mention, and Delia had just flagged it at the beginning of her presentation, is the project will be completed in March. And then in April, we'll be providing public sessions where the project team will be presenting the results and recommendations in each Atlantic province. So we will be there in person, but if you can't make it, we will also have a webinar, and all of that information will be posted, I'd say, in the coming weeks, month or so. We'll figure that part out, but just keep an eye out for it because we hope to have a lot of you join us for that. So thank you all for being here today, and we hope to see you soon at one of the workshops. Thanks very much.
Thanks, everybody. Take care.